my friends. Now we are going to discuss our new lecture on non-destructive inspections. Through this lecture you can understand that there are so many various types of non-destructive inspections generally we are using for testing the different material characteristics. So, by this particular lecture we are going to discuss about the visual inspections. So, now first let us know that what is non-destructive inspections. So, non-destructive inspections, from the name itself you can understand that basically we are not destroying the materials, that means we are not hampering the materials, neither we are giving any load, pressure or anything or maybe any touch to that particular materials. Just from the outside we are getting the informations about that particular materials. So, by definitions, so generally non-destructive testing is the process of inspecting, testing or evaluating materials, components or assemblies for discontinuities or differences in characteristics without destroying the serviceability of the part or systems. So, this is the main factor over there. So, now terms non-destructive examinations, in short generally we are calling it as a NDE, or maybe sometimes we are calling it as a NDI, that is the non-destructive inspection, and non-destructive evaluations NDE are also commonly used to describe this particular technology. It is highly valuable technique that can save both money and time in product evaluation, troubleshooting and the research. Yes, of course, sometimes it may happen that we are using particular materials. So, at the midpoint of that particular materials we can take it out and we can check it whether any cracks or anything has been occurred to that particular material or not, and then again we can put that particular materials for reusing it. Also, it allows the inspection without interfering with a product's final use. NDT provides an excellent balance between quality control and the cost effectiveness. Sometimes it may happen that as an maybe the user or maybe the operator, sometimes I am thinking that maybe this material can fail maybe after certain time or maybe really it has got some kind of damage. So, at the middle of the operations just we can take that particular sample or maybe that equipment or maybe the materials or maybe the parts, we can check it, and then if we do not find anything over there or maybe any severe damage over there, so later again we can put that particular materials and we can use it for certain time. So, by this way we can save the money and also we can save the time, because if the machine will failure after certain time, so automatically either we have to replace that particular part or maybe it needs some time to bring that particular parts. So, by this way we can save the time as well as the cost. Non-destructive tests are used in manufacturing, fabrications and in-service inspections to ensure product integrity and reliability, to control manufacturing process, lower production costs and to maintain a uniform quality level. So, not only that when you are using that particular materials we are doing this kind of testing, no, at the time of preparing that particular materials also, when we are doing some batch productions, in between that productions also we can test this particular testing. During constructions, NDT is used to ensure the quality of materials and joining process during the fabrications and the erection process, and in service NDT inspections are also used to ensure that the products in use continue to have the integrity necessary to ensure their usefulness and the safety of the public. Yes, of course, sometimes it may happen that if the material will fail in between, maybe it can damage the other parts or maybe it can damage the operator. So, it is better, means or rather I can say it is quite advisable that in between the operations we should do this kind of testing frequently, so that we can minimize the cost, we can increase the productivity time as well as we can sometimes save the human life. Now, what are the use of this kind of NDT methods? So, generally use of NDT we are doing for the medicines and art, forensic engineering, mechanical engineering, petroleum engineering, civil engineering, electrical engineering, systems engineering and of course, the aeronautical engineering. Now, generally these evolutions can be conveniently divided into 9 distinct areas. Okay. So, first is that flaw detections and the evaluations. So, whether while doing these operations or maybe while doing any kind of operations, whether in between that if there is any flaw or maybe there is some error, easily we can detect. Leak detections, suppose we are sending some kind of gas or maybe the fluids or maybe the some kind of liquids through a pipe. So, easily we can detect that whether any leakage is there inside it or not. Next is the metrology, that measurement of the dimensions. Say suppose I am using certain materials for certain applications. So, after certain time I can check that whether there is any due to that frictions or maybe the heats, the material shape and size has been changed or not. So, the best example is the bearing, generally we can do it. Then next one is the location determinations, structure of microstructure characterization. Sometimes it may happen that we are using certain kind of materials where the heat generations is more. So, due to that heat generations, whether the any kind of heat treatment kind of things is going on to these particular materials or maybe the material is changing its own properties, that kind of testing we can do. Then estimations of mechanical and physical properties, stress strain or maybe the dynamic response determinations we can do. We can do some kind of signature analysis, and last one is the chemical composition determination. Now, how to select that which method or maybe the which technique is best for this particular testing, because there, as I told already, there are n number of testings, but it is not possible that every time to do all the testings for a particular material. So, it depends upon the applications, it depends upon the material properties, it depends upon the which kind of materials you are going to use or maybe where you are going to use. So, basically each NDT method has its own set of advantages and disadvantages, and therefore, some are better suited than others for a particular applications. The NDT technicians or engineer must select the method that will detect the defect or make the measurement with the highest sensitivity and reliability. Yes, of course. Say suppose for testing a particular materials measuring the shape and size, there are maybe 2 or 3 different types of methods are there, but as an engineer or maybe as an expertise only, we are the best judge that which method we have to follow, so that I can get the 100% error free result. The cost effectiveness of the techniques must also be taken into considerations. So, when planning for the NDT testing, one should take into account a number of factors. What are those? First is that requirements regarding reliable and safe operations. Second, quality assurance level achieved. Third one is the characteristics of manufacturing process, properties of materials used. Fourth one is the feasibility of NDT methods available, and the last one is the economic criteria. So, these all are the main criteria by which we can judge that which method is the best for my application. When we are using the NDT methods, there are NDE application at most any stage in the production or life cycle of a component. As I told already, to assist a product development, to screen or sort incoming materials, to monitor, improve or control manufacturing process, to verify proper processing such as heat treating, to verify proper assembly, to inspect for in service damage. So, generally when we are doing the design, after that we are doing the processing. In processing, to screen or sort the incoming materials. Say suppose first we have done the drawing, that what materials we are going to prepare. Then after that we are acquiring different materials. Say suppose I can give you the examples of composite materials. So, now we are taking 3 or 4 different constituents or components, now we are mixing them properly. So, now whether the mixing is proper or not, addition is proper or not, after that there is any pores or cracks or not. So, we are doing at the time of processing. After that we are doing the manufacturing. Say suppose I am doing the casting, or maybe I am doing some other operations, maybe I can make some kind of films over there, or maybe I can make some kind of products over there. So, to verify the proper assembly of that particular parts, and then after that I am using that particular parts into some applications, either maybe automotive parts or maybe some other parts, and while working of that particular parts we are checking that whether that material is working properly or not, or maybe in service it is creating, or maybe it is getting some kind of problems, or maybe creating some kind of errors, or maybe the noise, or maybe the vibrations. So, that is known as the in service monitoring. Now, what are the benefits of using the NDT in manufacturing techniques? So, first, it increases the safety and reliability of the products during operations. It decreases the cost of the product by reducing the scrap and conserving materials, labor and energy. It enhances the reputations of the manufacturer as producer of the quality goods. It enables design of new products. But one thing I can tell you, that NDT testing does not mean that the material will never fail in future, no, but I can say that it is a one kind of precaution technique, so that I can maximize the service life of that particular products. So, all of the above factors bring profitability to the manufacturer, that is the ultimate goal. Now, what are the techniques? So, there are so many techniques are available, but most popular techniques are like that: visual testing, liquid penetrant testing, magnetic particle testing, eddy current testing, radiography testing, ultrasonic testing, acoustic emission testing and the infrared thermography. Now, first let us discuss about the visual inspections. So, from the name itself you can understand that we are depending on our eyes. So, we are seeing that particular materials, and then after that we are taking the decisions that whether the material can workable, or maybe it can get some kind of failure, or maybe it can get some damage, or maybe the some error. So, generally the visual inspections is a non-destructive testing technique that provides a means of detecting and examining a variety of surface flaws such as corrosion, contamination, surface finish and the surface discontinuities on joints like weld, seals, solder connections and adhesive bonds. It is the most cost effective method of detecting common defects in welding and casting, as it can be implemented easily throughout the progression of a job. It is easy to eliminate simple errors or problems, preventing the follow on effect. Say suppose a continuous or batch processing is going on. So, sometimes we can take the samples randomly and we can check by our eyes, and if we see any kind of flaws or maybe the discontinuities, so certainly we can stop the productions, we can rectify the problems, so that it can save the money and wastage too. Next, it is also the most widely used method for detecting and examining the surface cracks, which are particularly important because of their relationships to structural failure mechanisms. But one thing I can tell you, that these surface cracks means these cracks has been generated on the surface, not inside the materials. If it is inside the materials, we cannot do it by the visual inspection. Even when other non-destructive techniques are used to detect surface cracks, visual inspection often provides a useful supplement. Next, how we can do this particular experiment? So, generally it is general recommendations for operator to be placed at a distance for his eye to be within 600 millimeter of the test surface at an angle not less than 30 degrees. So, suppose this is your total sample, right. So, in this particular sample you can see up to the maximum 300 millimeters or maybe the 12 inch. So, up to 12 inch distance you can see that material clearly, and the angle should be within this range. So, that means if I take 180 degrees, so you minus the 30 degree from this sides and 30 degree from this side. So, 120 degree you can see properly. So, if you keep your eyes here and if you keep your eyes maximum to here, you can see the material surface clearly. If it is below 30 degree, you cannot see the surface properly. The criteria set above is based on the eye's resolving power. Natural or artificial lighting of sufficient intensity and placement is needed to illuminate the test areas and to allow proper reading of weld gauges and other equipment. The visual test resolution is considered adequate when the examiner, by combination of lenses, axis, lighting and the angle of visions, can resolve a 0.8 millimeter wide black line or an artificial flaw located on the surface to be examined. So, this is the standard procedure. Now, there are three distinct classifications of the visual testing. So, number one is called the direct unaided visual testing, second one direct aided visual testing, and the third one is the remote visual testing. So, when you talk about the direct visual testing, direct visual examinations is the type of examinations made in situations where there is an access to the area of interest without any possibility of injury to the inspectors. So, that means we can directly see that particular zone. There is no interruptions between the eye and the object. Defects can be detected are cracks, corrosion layer, physical damage, surface porosity, misalignment of mated parts, etc. So, that means direct visual testing, in between the eyes and objects there is no barrier. So, these all are the examples where generally we are doing the direct visual inspections. Next, we are coming to the direct aided visual testing. So, from the name itself you can understand that aided part has been added, that means with the help of something. So, the nature of the image is not modified, modifications of the image is only allowed by magnifications with, for example, a mirror, a lens or an endoscope, spectral or density filtering by a filter lens. So, these all are the examples where we cannot detect this kind of cracks or pores by directly our eyes. So, we are taking the help of some kind of lens or maybe the mirror. Next, remote visual sensing. So, the nature of the image is modified. Suppose in our surface a very tiny crack or maybe the small crack is there, but we cannot see it by our naked eyes. So, that time we are using some kind of techniques which is zooming that particular zone, and by zooming getting that zooming figure we are getting some kind of informations about that particular materials, or maybe we are having a very complex shapes where we cannot see that particular problem directly. So, we are taking some kind of camera over there or maybe the some kind of video photography by which we are getting the image, and then we can understand that what is the problem has been happened. So, equipment used generally camera, robotic devices, fiber optics, portable video probes. So, these all are the examples where we are using some remote visual testing. Now, what are the basic procedure for visual inspections? So, generally it comprise of three steps. First one is the clean the inspection surface properly. Yes, of course, because if it is the new materials directly it is coming from the machines, that time sometimes it not required, but if I am using that material parts several times and then after that at the mid of the operations I am thinking that I need to check that particular materials. So, in that case I need to clean that material surface properly, because maybe some oil or maybe some grease or maybe some other paints is already there on the top of the surface. So, first is the clean the inspection surface properly. Contaminants such as oil, grease, kale, sand, etc. may interfere with interpretations of the results. Sand is coming when we are talking about the casting surfaces. Now, second one is that adequately illuminate the specimen with light. Yes, of course. So, give the proper lighting on that particular surface, so that we can get the best visual view. Human eye is most sensitive to yellow green light with a wavelength of 5560 angstrom. Next, third one is the examine the specimen with eyes or take the assistance of light sensitive devices such as photo cells. Now, what are the instrument? Different kinds of equipment are used to improve the inspection quality. This equipment can be classified into two parts. One is called the optical aids and the second one is called the mechanical aids. So, what is optical aids? So, generally there are several types of optical aids are available. So, one is called the lightning or illuminations, second one is called the inspection mirrors, especially for small or maybe the angle mirrors, magnifiers, generally magnifying glasses or maybe the microscopes, borescopes and fiber optic borescopes, and other equipment like video borescope, robotic devices, etc. So, what is lightning? The inspection surface illuminations is of extreme importance adequate illumination levels should be established in order to ensure effective visual inspections. As I told already, we need a clear light over there to see that particular cracks or maybe the defects. While designing lighting for an inspection system, we must consider what the inspection system should do. Look for a defect in a part or maybe measures a part dimensions or maybe determine the presence or absence of a feature. While devising lighting for products inspection, following things should be taken into account. Optical properties of product surface. It should not be very glossy, the light will fall onto it and then it will reflect directly to our eyes, so that we cannot see properly. Inspection surface geometry, and the last one is that color of product surface. Sometimes it may happen that whatever the light we are putting onto that material surface, it can absorb that light, so that we cannot see it properly. Optical properties of product surface. So, generally the surface of products have optical properties that fall into one of three general reflectance categories. What are those? First one is called the specular reflection, second one is called the diffuse reflection, and third one is called the directional reflection. What is specular reflection? The specular reflection is a phenomenon where the incidence angle of light is equal to the angle of reflection. That means, in this particular case the incident light is coming this way and the reflection is taking in this way. So, that means, in this particular case the theta 1 is equal to theta 2. Specular surfaces are mirror like smooth and highly polished surfaces. Next, diffuse reflection. It is the reflection of light from a surface such that a ray incident on the surface is scattered at many angles rather than at just one angle, as in the case of specular reflections. So, when the incident light is coming for specular inspections, it should go through the blue color, but in the diffuse reflections it is going into the different angle. A surface built from a non absorbing powder such as plaster, or from fibers such as paper, or from a polycrystalline material such as white marble, reflects light diffusively with great efficiency. So, these all are the examples. Diffuse surfaces are rough and have a dull luster. Many common materials exhibit a mixture of specular and the diffuse reflection, and the last one is called the directional reflections. So, directionally reflective surface typically contain fine groups that reflect light generally in a preferred directions depending upon the incidence angle. So, when we are putting the light on the sawtooth, so in that case you can see this kind of directional reflection over there. Next, surface geometry of inspection surface. In addition to a part's reflective properties, the surface geometry must also be considered. What are those? First one is called the flat surface. Flat surface is self explanatory, and achieving uniform illuminations across it is typically easier than other geometries. Second is the curved surface. The changing of slope of a curved part can often pose a lighting problem that manifests itself as uneven illumination across the part. If the curved surface is specular or directionally reflective, glinting can occur too. So, suppose I can give the examples of this one. If there is a flat surface, so simple, the light is coming, then it is reflecting, I can see it clearly. But when we are having that curvy nature, so some lights are going in this angle, some lights are going into this angle, that time it is very really difficult to see all the portions of this particular material. And the third one is called the prismatic surface. Prismatic parts contain sharp edges or steep slopes, and such parts can be difficult to illuminate because lighting can produce shadows or maybe the glints. Color of inspection surface. Contrasting colors may help your inspection systems distinguish parts from backgrounds. If contrast differences are small, we can use color filters or selective wavelength illumination to enhance the contrast of our inspection system. Yes, of course. Say suppose I am having a sample black in color, and below that if I keep any kind of black surface, so it is very difficult to get the image or maybe do the inspections. So, I need a white color or maybe some kind of reflective kind of materials, so that easily I can see the materials properly or maybe the parts of that materials properly. Next, illumination techniques. So, there are different types of illumination techniques are available. First one is called the front illuminations. So, from front illuminations involves placing a light source and a camera observer on the same side of a product to provide the overall illuminations. So, that is called the front illuminations. So, here I am having that object and the light is coming and observer eye is over here. So, that is known as the front illuminations. Then oblique illuminations, placing a light source nearly perpendicular to a camera or maybe the observer provides a oblique illuminations. These techniques is used to find surface irregularities such as bars. So, this is the object, I am putting the light in these directions and then after reflecting the light is coming to the observer eyes. So, we are getting the image. And third one is called the coaxial illumination. So, it is another form of front lighting which directs lights down a camera observer's line of sight. Because this technique provides uniform illumination across your field of view, it can reduce shadows and some glinting. So, light sources are over there, I am using some kind of half mirror over there. So, it is reflecting the light onto the object and then from object the light is coming to the observer eyes. So, in this way you can typically adjust the spot area or maybe the light where actually you want to see. Next one is called the diffuse back illumination. So, the object is illuminated from the behind, it gives edge contrast to objects as well as aid in identifying defects or imperfections within translucent or opaque surfaces. So, in this case the light source is behind the object and through that the light is coming to the observer eyes. Next one is called the collimated back illuminations. It is a variation of backlighting which uses collimated light to produce images with sharp edges even for curved surfaces such as those on a cylinder or ball. So, this is the known as the collimated back illusion. And directional front illumination, directional lighting lets an inspection system measure shadow and calculate the heights of the components itself. So, there are several techniques by which we can illuminate the object and we can get the best results. Then next one is called the inspection mirrors. Inspection mirrors are used to improve the angles of vision. Inspection mirrors allow the inspectors to look inside piping, threaded and bored holes, inside castings and other hardest to see places. The best example I can tell you, then when we are taking our car or maybe the vehicles to some complex or maybe the malls, generally they or maybe some good hotels, they are checking by this illumination mirror by the lower part of our car, that is there is any kind of problems or not. Then next one is called the magnifiers. Magnifying systems are used for evaluating surface finish, surface shapes, profile and contour gaugings and surface microstructures. An inspector with eye fatigue is likely to miss defects that would otherwise be detected. Yes, of course, because of course being a human being we are having certain limitations. It does not mean that we can see any kind of defects of any size. So, sometimes it may happen by naked eyes we are not able to see those kind of defects. So, that time we are taking the help of this magnifying glass or maybe the microscope, so that any very tiny defects or maybe the cracks we can see very easily. Therefore, it is important to ensure that the possibility of eye fatigue is minimized by using appropriate level of magnifications for this particular job. The equipment should have proper ergonomic functions such as adjustability and the positionability. Next is called the borescopes. So, borescopes are visual aids used for illuminating and observing the internal closed or otherwise inaccessible areas. They are designed for remote viewing in difficult to reach areas such as jet engines, cylinders, tanks and various enclosed chambers. They are available in many different diameters and lengths and are classified as rigid and maybe the flexible. So, this is the schematic view of the borescope. So, borescope, so generally when we are having that object, simultaneously it is giving the light as well as it is giving us the image. So, this is known as the rigid borescope and this is known as the flexible borescope. Other equipment like portable video probes. Portable video probes allow inspectors to remotely perform examinations in closed chambers which are inaccessible by conventional inspection means. Portable video inspection unit with zoom allows inspection of large tanks and vessels, railroad, tankers and the sewer lines. Then next one is the robotic devices. Robotics have been developed whereby cameras can be affixed to crawlers and the submersibles. Nowadays we are using these devices widely. Say suppose we are using it for the petroleum industry to check the things inside the pipe. Sometimes we are using it for the sewage purpose, because in sewage we know that it is not accessible to the for the human being, because maybe there is the generation of some kind of toxic gases or some other means. So, that time we are putting these robotic cameras inside the pipes or maybe the drainage systems, and we are taking the image of the hole from the outside and then we can solve the particular problem. Robotic crawlers permit observations in hazardous or maybe the tight areas such as air ducts, reactors, pipelines. Retrieval tools can be affixed to robotics to remove the foreign objects. Next, second one is the mechanical aids. Several mechanical gauges are also used to assist the visual inspection examinations. So, those are some kind of screw pitch gauge, some kind of angle measuring tool, outside caliper, vernier caliper, micrometer, level indicator. So, generally mechanical aids are like this for measuring rules and tapes, generally used to measure the distance, plumb lines to determine the vertical on and upright surfaces, lever gauges used to measure level of fluids at various industrial applications, calipers and micrometers to measure the dimension of product more precisely, angle measuring tools for angle measurement like bend angle measurement in sheet metal working for bending testing, thread pitch and the thickness gauges generally for screw thread measurements. So, we are using various types of mechanical aids to get the perfect information. Mechanical aids for weldments. So, generally we are calling it as a welding gauges. Welding fabrications use fillet gauges to determine the width of the weld fillet, undercut gauges, angle gauges, skew fillet weld gauges, pit gauges, contour gauges and a host of other specialty items to ensure the product quality. So, what are the examples? Like universal welding gauge, it allows the measuring of height of flat weld, height of fillet weld bit, thickness of fillet weld, bevel angle of weldment, undercut depth of weld seam, vertical misalignments. So, generally the universal welding gauge looks like this. Second one is that fillet weld gauge, it allows the measuring of concavity or maybe the convexity of fillet weld. So, generally the fillet weld gauge looks like this. Now, what are the advantages of visual inspections? It is a routine procedure, the cost of visual inspection is low, it can be very effectively where examination is made before, during and after manufacturing process. As I told already, testing is very simple and the testing speed is high and also less time consuming. Testing is possible while test object is being used, permanent records are available when latest equipments are used. Limitations of visual inspections, of course there are certain limitations. The scope is limited to surface defects as internal and subsurface defects cannot be found, I told already. Limited to the visual acuity of the observer and inspector, yes of course we are having certain kind of limitations, we cannot go beyond that. Eye fatigue may cause the defects to remain undetected. Now, we have come to the last part of this particular lecture. So, as a summary we can say that non-destructive inspections is a wide group of analysis techniques used in science and technology industry to evaluate the properties of a material, component or system without causing any kind of damage to that particular material. It is divided into various methods each based on a particular scientific principle. Visual inspections is the most common and widely used non-destructive testing techniques, and it is normally the first step, generally we are calling it as a first step of any examination techniques. Various optical and non-optical equipment are used to further assist or maybe the improve the visual inspection examinations. Thank you very much.